This is project number 1, video number 1, the one in which I do the pencil on paper part of the solution to the project. We've got object number 1 sliding along a frictionless horizontal surface, bumps into object number 2 with a given mass of 1 kilogram for object number 2, and with object number 2 being initially at rest, they stick together, slide off as 1, and we're supposed to write a MATLAB function that calculates and returns the percentage of the mechanical energy converted into other forms given the mass 1 of the object. So the user will have to provide that. So the user of our function. So let's get started by drawing a before and after picture. Before, we got object 1 sliding along with a velocity I'll call v1. It's got a mass m1 before object number 2 of mass m2, which is 1.00 kilograms, is at rest in the after picture. We got the two of them stuck together, sliding off as 1 with a velocity I'll call v prime, and they've got a total mass, or that final object, the combo object, has a mass of m1 plus m2. So if we apply conservation of momentum, we'll say the sum of the momenta to the right in the before picture is equal to the sum of the momenta to the right in the after picture. We've got m1 v1 here, it's the only one that's moving, and m1 plus m2 quantity times v prime in the after picture. So v prime is equal to m1 plus m1 divided by m1 plus m2. Just divide both sides by m1 plus m2, and then of course times the v1. Alright, so I'm going to need that result, but certainly not my answer. What I'll then do is say the percentage energy lost I think I'll call it converted from mechanical energy into thermal energy and permanent deformation energy, is going to be what I started with minus what I wound up with. That's how much is lost. And then I'm supposed to express that as a percentage of the original, so I divide by the original and then times 100%. So it's all kinetic energy, so all these E's can be replaced with K's. Capital K's. And then it's 1/2 mv1 squared minus 1/2 m1 plus m2 times v prime squared, and then all divided by the 1/2 m1 v1 squared. Alright. Those halves cancel. And then let's use our expression for the v prime. So I'll do substitution here, but pure substitution. So it's M1 V1 squared minus M1 plus M2 times this quantity squared V1, and that's all squared, and then divided by M1 V1 squared. Alright, let's say I got a V1 squared up there, there, and there, with the square on the outside. And so the V1 squareds cancel. If I this M1 plus M2 cancels out one of these. It's in the denominator, but it's squared, so I just get rid of one of them. And if I divide M1 into both terms, I get a 1 there, and I'll cancel out one of those. So the percent energy converted is just 1 minus M1 over M1 plus M2, then times 100%, which I left off. In these two steps. Okay. So let's see if we can simplify this a little bit. This will be percent energy converted. I'll put it over a common denominator. So this becomes M1 plus M2 minus M1 all over M1 plus M2 times 100%. And M1 minus M1 is 0. So I got this is equal to just M2 over M1 plus M2, and then times 100%. And that's our answer for the percent energy converted from mechanical energy to other forms. We should check to make sure it makes sense. Let's see, if M1 is really, really light, it's just it'll be like sticking into a wall. And if M1, and the limit is M1 goes to 0, we get 1 over M2 over M2, which is 1. We get 100% energy converted. That makes sense. And if M2 is really, really light compared to M1, if I take the limit as M2 goes to 0, it goes to 0. A car bumping into a bug, for instance, it doesn't change the energy of the system. So that indeed I get 0 for that, so that makes sense. The units work out. Obviously, it's just a plain percentage, so the answer seems reasonable. So let's call that our solution to the pencil and paper part of project number 1. Oh, wait a second. We got to do an outline. We got to submit an outline of the code. So let's go a code outline, or let's see exactly how I phrase that in the project. So you got to complete algebraic solution and an outline of the steps that the program will create. So yeah, we'll call that a code outline. So I'll go 1. Take M1 as argument, 2, calculate, and return percent energy converted is equal to M2 over M1 plus M2 times 100%. And that's actually all there is to this one, so our code outline is very short. Alright, I think that ends the pencil and paper part of the solution to project number 1.